Greetings and welcome to the Exro Technologies Conference. It is now my pleasure to introduce your host, CEO Sue Adzemir. Thank you, Ms. Adzemir. You may begin.
Good morning, everybody. Thank you very much for joining to hear a little bit about Exro. I look forward to talking you through, and I'll leave time for questions at the end. My name is Sue Adzemir. I am the CEO of Exro Technologies. I joined Exro in September of last year. I've spent my entire career in the electric motor business, including my last 10 years before joining Exro. I was CEO of the GE Industrial Motor business. I joined them initially as a Western Canada sales manager and worked my way up to an Eastern Canada, then a Canadian, then a North American sales leader, and finally the CEO of the GE Small Industrial Business Unit based out of Houston, Texas. In late 2017, I led the acquisition of our business unit to a company called Wolong Electric, which is one of the top Chinese manufacturers in the world. And they have a 10-year branding agreement with GE and asked me to stay on as the CEO of the GE Industrial Motors Company, a Wolong company. So I was doing that when Exro approached me. And as I took a look and did my due diligence, I realized that Exro has a fantastic technology that could really transform the market, and they needed to put some strategy and commercialization plans, and I decided that was a good move for me. So I'm going to jump right in. What Exro does is make electric motors smarter, and how we do that is through the power electronics. Our technology actually feeds into an electric motor to provide the equivalent of an electric gearbox. From a company perspective, really what we're driven by is find a new way to think about energy consumption in the world. As we look at the transition to electric vehicles and electrification in general, our mission is to use minimum energy for maximum results, to really understand the best way to get more out of doing less. Late last year, we made the decision to focus on the mobility industry. The reason we made that decision is because it's a really good fit for our technology. Our technology is completely scalable, but we find the best benefit is where we have a wide variable torque range. So what that means is we need the ability to have a very wide torque range with the need for speed or performance. So before I get into the details of our technology and our electric gearing, what I want to do is just take a step and make sure everybody understands what comprises a powertrain for a mobility industry. So we call mobility for us is anything with wheels on land. Those powertrains, the way they convert energy, the way they utilize the energy is through the battery, the motor, and the power electronics. Within the power electronics sits an inverter and controls. Our driver replaces the existing inverter in the powertrain today. All of our technology is based on a physics of electric motor called coil switching. We did not invent coil switching, nor is that where our patents sit. We currently have over 18 patents granted worldwide and 17 patents pending. For us, what our technology does is it allows our driver, our inverter, to create the effect of an electric gearbox in a single motor. This is done through taking coil switching into the 21st century, applying intelligent, smart algorithms that allow the motor to now sense when it requires that need for torque, that low-end torque, or that need for speed or production. And again, it's completely dynamic. So it's happening, and the rider or operator of the equipment actually won't feel it switching gears. The problem in the industry right now is that the electric motors of today aren't built to handle the type of torque and speed that are required in most mobility applications. So what's happening is that Tier 1 automotive or inverter or motor manufacturers are compensating for that. So what they do is they put in oversized motors, or often two or more motors. There's a couple of different vehicles coming out of Europe now with motors in each wheel. Or they install a gearbox or two or more gearboxes, like the new Porsche Taycan has 2 gearboxes. What they're really doing is trying to compensate for that need for speed and that need for torque. By utilizing our technology, we call it a coil driver. You're able to now create the effect of that gearbox inside of the motor, so an electric gearbox. And what it does is it switches the coils to be able to achieve that low-end torque or that high-end speed as many times as needed throughout the torque profile. We believe that we are the first to market for doing this from a power electronics standpoint. And when you utilize our technology, you now optimize the system. What that means is that you're able to get greater efficiency out of the complete system because you can now reduce or eliminate that additional gearbox. You can now reduce or eliminate that secondary motor. And if there's not two motors or there's not a gearbox, you can still use our technology and reduce the existing motor because you're going to get more out of the single motor that exists. Again, we are not a manufacturer of inverters. While we are producing the hardware, the black box that sits in it, and our technology and our patents sit around the topology of that as well, we are about the technology of it. We're driving and delivering the algorithms and how they fit into that inverter. Just so that everybody understands how that's working, and for those of you that are in Calgary or visiting Calgary anytime soon, please reach out to Jake or myself and we'd be happy to host you here at our center. But really, if you picture riding an electric bike up a hill, as you go up that hill, it's hard to get the performance with the torque pull. So you're going to have a hard time riding that bike. As you put somebody on the back of your bike, your best friend's riding on the back of the bike with you, it's going to get even harder. That's because that motor can't now drive that torque and maintain the speed at the same time. That's a user experience. So we take that user experience into the transition to electric vehicles for passenger vehicles and for commercial and municipal vehicles. And it's actually a barrier to entry. It's actually one of the things that's preventing commercial fleets being able to transition to electric fleets because they're draining out batteries. They're not able to achieve as much as they need. So you picture that delivery truck. In the morning, it doesn't have anything in it. So maybe it's pulling up the hill. It's doing an okay job. It's not really a big deal. As the day goes on and it has more packages in it and it gets heavier, there's more torque on it. Now it's not meeting the kilometer per hour rating even to be able to perform what it needs to perform in a day. By utilizing the Exro technology, we allow that vehicle to be able to pull the full torque load that it has at the speed limit that it needs. We increase what's called gradability, the ability to pull up the hill. And in most cases, we're able to greatly reduce the weight of the powertrain, meaning that now they can get more draw on their battery. So essentially, we're creating a scenario where they can go farther on the same single charge. That's huge for the commercial vehicle market. It means now maybe they can pick up one additional package a day, maybe two. It opens up a whole new cost of ownership for the automotive manufacturers. Really what happens is our driver or our inverter connects into the leads of the electric motor. This does mean that we need a partnership with the electric motor manufacturers as well. And by partnership, we just need a certain connection diagram. Coming from GE, running a facility, I can tell you that every single motor that we ship out the door has multiple connection diagrams. Something as simple as shipping to Canada versus shipping to the US would have different connection diagrams. It's not a cost implication for the manufacturer. It's a change in the final connection. We need what's called all leads out. So it means we need no connection done. And the reason we need that is because we need access to the entire coil of that electric motor. Once we have access to the entire set of coils, we are now able to access the additional torque and speed ability of that original motor. So this translates into more efficient use of the stored energy that we're consuming inside of that powertrain. And again, that means we can go farther on that single charge. Our first proof of concept sits in a hub motor in the Motorino electric bike. This is the bike that we have sitting here in our lab. On this one, we were able to achieve over 25% greater torque and speed. And when you ride the bike up the hill, we actually have a little LED indicator on it. That's just for our demo bike, so that the user can see that it's actually flipping from gear 1 to gear 2 to gear 1 to gear 2. When I joined in September, one of the first milestones that I wrote was around the fact that we wanted to focus on commercialization. We wanted to start making that roadmap to revenue because we knew that that is many months for the mobility industry. Knowing that our application is completely scalable, that can go into any variable torque application, We also recognize that all of the automotive manufacturers have customized powertrains. No two autos on the market right now utilize the exact same powertrain. So while we are completely scalable, we're not a plug and play. We need to customize into that existing system and have partnerships that put us on the road so we can get the automotive testing for on-road testing completed as well. My commitment upon joining in September of last year was to sign 8 commercial deals, enter into 8 commercial deals that would co-develop with us before the end of 2020. As of 2 weeks ago, we were at deal number 7, and what we wanted to demonstrate was that we are scalable. So we have everything from an electric bike to a snowmobile to a motorcycle to agricultural equipment, car, and most recently a delivery van. But we also wanted to show that we had partners interested in helping us take this technology into road tests. We build in-house to automotive standards, and then these partners then take it to the road and complete the on-road testing for us. Kind of the 2 big deals that I'll focus on with the limited time we have today are Zero Motorcycle, which we signed early last month. Zero Motorcycle is a leader in the electric motorcycle industry. They were one of the first to market with an electric motorcycle, and they sell thousands of units per product line. We just signed that deal last month. We're in development with them right now, and we anticipate delivery of our product to them in January. After we deliver a product, our customers need to then take the road test. So it takes anywhere from 3 months to 6 to 9 months to be able to complete all the required road tests. And then we'd be able to enter into an agreement for product and delivery, which would drive revenue. The last deal that we signed was about 2 weeks ago, where we signed with a partner called C Electric. C Electric is enabling us to finish our technology roadmap and get a 800 volt on the market before the end of next year. The project with C Electric, they're a manufacturer that's based out of Australia. Their CEO actually sits at their North American headquarters in Los Angeles. And what they do is they have partnerships with tier 1 manufacturers like Ford, and Iveco. And they take those empty chassis, so they buy an empty delivery van or an empty garbage truck, an empty cement truck, and they install their technology, which is a full powertrain. And then they turn around and sell it to the market as an electric vehicle. We will participate with them on a co-development of the powertrain where they'll utilize our inverters to be able to get superior performance and efficiency out of their technology. That allows us by the end of this year to have 3 major proof of concepts. The first one is for what we call a micro-mobility or 2-wheel application, which was the Motorino bike. The second one is what we call a 100 volt application, which is the project we're doing with our partner Potencia out of Mexico, which is actually converting municipal and fleet vehicles. They pull out the gas engine and install their Fonto Power flexible powertrain. And then the 800 volt will deliver in the 3rd quarter of next year with the electric. And then the other ones on the map fit into Aurora and Clean Feed and the other partners that we've signed to date. We fully anticipate, although there's no guarantees, that we will have the 8th deal signed in the 3rd quarter of this year. We have a very strong pipeline and many customers that we're currently in negotiations with. I always like to take a minute and just review how the business model works so everybody understands what it means to enter into a partnership with XRO. The first stage is always what we call our due diligence. So this is where we're entering in, we're understanding the different technical requirements of the project, and we're applying some basic formulas and algorithms to see what value our technology would bring to the product line. This is what fills up our pipeline and not things that we release out to the market because we're not sure if it's material or not yet until we confirm that we have value for the customer. Once we've partnered with somebody and we recognize that we have value, we enter into our proposal stage. This is where we're optimizing the system. This is where we'll put out a press release like what we've done with Zero and with the Electric and the others. And this is really signaling that we have interest on a co-development. We have access to a high level of data from our supplier, from our customers, and for ourselves. And we're going to now be allocating our resources and our funding into developing our driver for that application. That process, that second step, takes us about 4 to 6 months, sometimes a little shorter, sometimes a little longer, depending on the size of the inverter that we're building. From there, we're in full development and design. That's within that same period. Once we've finished the development and design, we've completed a proof of concept for that customized powertrain and what we call sample A or B in the automotive segment. What that really signals is that we've made an automotive standard, automotive ready inverter that now needs to be completed the next 3 phases in a road test, and that's where we go into customer acceptance. It can be anywhere from 90 days to about 6 months. Once the customer accepts it, then we enter into our production stage, that's where we would start to see revenue. From the production stage, we are not a manufacturer, again, like I touched on at the beginning. So what we do in-house is design, final assembly, and testing. We do have a state-of-the-art facility, which we were able to put together through our fundraisers. We have a very large dyno bay, which allows us to full load test, which is being built up in our center here in Calgary right now, and we'll be ready, the whole lab will be ready in October. And then all the other things that we build up, we do a lot of the PCB and electronics we build here in-house, but a lot of the mechanical and the control box itself, the heat sinks, we have that contracted out with third-party agreements. Besides myself, I am surrounded with a team that is helping us to move as quickly as we're moving, sign these deals, and execute as aggressively as we're doing. I have John Meekiston, our CFO. John's a lifetime CFO who has worked with companies like Hayward and definitely helps to keep our bank account strong and drives our financial strategies. Josh Sybil, I recruited in November of last year. I met Josh while working at GE. Josh is a mechanical engineer who worked at the Peterborough motor plant designing motors, and he was at Siemens Canada for the last 6 years. He was leading their Canadian mining segment, a P&L leader for the Canadian mining segment, and we recruited him to join EXRO in November. In May, I recruited in a new chief engineer, Eric Kutz, who comes to us from KSR, which is one of the leading power electronics manufacturers. Eric has spent his career supplying inverters and power electronics into the automotive industry. And then just on Friday, or Thursday or Friday of last week, I announced the last piece of my executive team, which is my chief marketing engineer, and that is Richard Moe. Richard is a graduate of the commercial leadership program at GE and was part of my GE and my Wolong team. After I left Wolong, he was promoted up to the global marketing and digital leader for Wolong globally. And Richard and his wife are joining us here in Calgary as our new chief marketing. On a board of directors side, our chairman is who I'll focus on so that I leave some time to answer the questions that are coming in. Mark Godsey is our executive chairman. Mark is a serial entrepreneur who has co-founded and exited 2 very successful biomedical companies along with a lot of other companies. The 2 we'll focus on is ID Biomedical, which was one of the top vaccine companies in North America and exited for over $1 billion. And Angiotech, which created the coating for the titanium heart stent. Mark is instrumental to where we are today and how we continue to strategize and present with our company. And then I also have Eamon Percy. Eamon is the retired VP of Operations for Ballard Power. Ballard is a hydro fuel cell manufacturer located in Vancouver. And I also have a business advisory board which supports me, which has everything from ex-GE officer Daryl Wilson to the current services director for Canada, Veronika Schneider, to Werner Kurtz, who is based out of Germany, a 25-year motor and control engineer for Siemens Canada. From a commercialization, from a capitalization table, we have 113,000 shares outstanding. We recently concluded a financing raise where we oversubscribed an investment banker led through Gravitas round mid-July, and we closed over $8 million. We were out raising $5 million. We currently burn around $500,000 a month, so we have a very strong bank account. We weren't actually low on our finances, but with COVID and the uncertainty in the world around us, we decided that we wanted to stay financially strong, and so we went out to raise a little bit earlier than we had initially planned, And it was, as I said, a very successful round. So we're able to now go a little bit faster, and we have runway through the end of 2021. With that, I am going to thank everybody and open up for Q&A. I've got a couple of questions coming in, and we've got about 5 or 6 minutes to answer them. So if you have any questions that I don't get to today, then please feel free to reach out to myself or Jake Beaumont, our VP of IR, and we would be happy to answer that. So the first question I see here says, how long until you are in the commercial market? So we're technically entered into the commercial market right now, but I think we'll start to see revenue later in 2021. It will be small as we continue to get through proof of concept and road tests and sign additional deals into 2021. We see ourselves forecasted to be EBITDA positive by the end of 2023. The next question says, you mentioned electric motors and batteries are oversized to accommodate the lack of torque available. Can I shed some light on how oversized these batteries and motors are? It's really particular to the specific powertrain that we're working on. So again, if I look to the Porsche Taycan, they have 2 gearboxes, and that's a new design, and an oversized motor. If I look to a different product, they may have 1 oversized motor. If I look to a company out of Europe, they have 4. So it's very, very specific. In general, from a cost perspective, of course, when they have the gearboxes, that's the best cost scenario for us. But in general, we find ourselves being equivalent to what they're currently paying for an inverter, but bringing in the additional gearbox application, or within 5% either way. So from how many more miles you'd get out of the battery, we haven't released that data yet, being that a lot of our information, we're just starting to come into the proof of concept and commercialization journey. We wanted to gather a little bit more data past what we've simulated and what our first proof of concept gave. So we hope to have all that data out to market before the end of this year. What we do know is that we are going farther on that battery charge, and we're getting an overall system efficiency gain of anywhere from 0.5% to over 5%, depending on what it is. Just give me 1 minute. I'm just having trouble if Keith's still on. I can't move my screen to get the rest of the questions, but I can see them all. I'm going to answer one more that I can see here. So the comparables between how the vehicle would perform between our driver and an existing performance is what we would call how many additional kilowatt hours we're getting. Again, that's a piece of data that we're piecing together. In the torque, I'll give you the example. We did a case study where we looked at garbage trucks. So this question is around how does my performance compare? So in the garbage truck that we compared, they were using the largest available traction motor on the market today for an electric garbage truck. It's a 29-ton. It's called a Class 6 truck. So what we did was we did a comparison using our Exro technology. We were able to increase the torque and speed by 15%. We were able to increase the gradability to the target that the customer asked us for, which was over 6% increase. And we were able to decrease the entire powertrain by over 30%. So this means that they are now able to install a larger battery or go farther with the existing battery. 30% is a huge amount. It's the biggest we've been able to see, but it's a really big vehicle. As we look to the same comparison on a smaller, it's called a step-up van, like what you'd see for a Kia or Amazon or UPS or FedEx, we were able to achieve, again, greater than 15% speed and torque. We were able to get greater than 10% on the gradability, and the weight of the powertrain remained relatively the same. So there's different ones according to how we do it, but we always see quite a substantial gain on the torque and speed, which is our main scenario. We're trying to get as much torque as we can to allow them to eliminate those additional mechanical parts or motors that drive the gears for them. I do see that there's a few more questions in the box, but I can't turn my screen. I don't know if it's frozen, so I'm going to thank everybody as we're at the end of the time, and for the questions that I wasn't able to answer, we will be answering them by email after this call. I thank you to everybody that joined, and again, please visit us at EXRO.com, and we're traded on the CSE as XRO and on the OTCQB as EXROF. Thank you very much for your time, and I appreciate it.